I'd like to make a brief video sort of showing how molar conversions can be done when there are a bunch of intermediary conversions. And the idea here is to sort of understand what we're being asked and what we're given, and then sort of work our way towards a conversion factor which can give us our answer. And I'll tell you what I mean. In this question here, it's asking us how many kilograms are present in a sample of carbon tetrachloride that contains these many amount or this amount of atoms of chlorine. So really, I mean, we're looking at a compound, and we know that this compound is carbon tetrachloride. And we know that that compound is also a molecule, a molecular bond. And it's a molecular bond. It's not an ionic bond. It's a molecular bond because the name of this compound was used or was named by using prefixes, and that only occurs with molecular compounds. So there's one atom of carbon, right? And there's 4 atoms of chlorine because it's tetra, and tetra means 4. So there's this compound here, it's CCl4. And this compound is essentially, it contains these many amount or this amount of atoms of chlorine, and it's asking us, okay, if you're given that information, how many kilograms are present in the entire compound? And so you can think about it like, okay, if I had a certain amount of atoms of chlorine, how much would the entire compound be in terms of kilograms? And so that's what's being asked here. And so just using our knowledge about conversion factors, what we really want to do is we want to go from kilograms of chlorine to, or kilograms of CCl4, it's actually not chlorine, it's CCl4, grams of the compound to atoms of chlorine. And what that would do is that would allow us, I mean, if we had this ratio, if we had an X amount of CCl4 equated to how many atoms of chlorine that would be, we could use that conversion factor and toggle any of the two and find out how much atoms we would correspondingly have, or how much kilograms we would correspondingly have. In other words, I could change, if I had a conversion factor, if I had any conversion factor, and it doesn't matter what the number is, if I had a conversion factor that takes me from that is X amount of grams of CCl4 or kilograms equals atoms of chlorine, then I could use that to, and sort of I could use that in a convenient way to plug the information that I'm given in the question and then find out how much kilograms that would be. So, the entire question is sort of centered around being able to get to this conversion factor. And so the first step insofar as actually doing so is to understand how you would get there. It takes a little work to get to this conversion factor here. And the first step here is, well, let's sort of consider our conversion factors that we know. There's the whole Avogadro's number of grams for a particular element equals X amount of moles, but that's for particular elements. It's not for compounds. In the context of compounds, we know that molar mass gets us to grams. It would get us to grams of CCl4 equals moles, or equals a particular amount of moles, 1 mole, of molecules. Now that is sort of a step closer, right? I mean, if we have that, we're not particularly at atoms yet, but we're at least at molecules. But you also notice that there's a problem. The molar mass conversion takes us from grams of CCl4 to molecules of CCl4, and our conversion is kilograms of CCl4 to atoms of Cl. So we're going to have to do a little more work after we actually get that conversion factor. So the molar mass conversion will get us from this to grams of CCl4 to molecules of CCl4. And then after we have that, you could just say that, well, let me go ahead and find out how many atoms of chlorine there are. Or actually what you could do is you could change your grams to kilograms, so that instead you can say that, okay, well, these many kilograms of CCl4 are these many molecules of chlorine. And in this case, it's not supposed to be CCl4, it's supposed to be chlorine. Oh, or actually, yes, in this case, it would be CCl4. So CCl4. So, you know, we're one step closer. It sort of resembles our original, the desired conversion factor. You know, we were at grams of this compound to how many atoms of chlorine. That's what we wanted. But, you know, in our conversion factor, and sort of the second step here, we were able to get from that, we were able to get to grams of CCl4 to molecules of CCl4. And then we're like, okay, well, why don't we just change the grams to a kilogram equivalent, and we'll get kilograms of CCl4 equals molecules of CCl4, because the moles with the molar mass conversion are actually in terms of molecules. But then, you know, you recognize that you want atoms of chlorine, not molecules of CCl4. So how many atoms would be in, you know, we would have a particular amount here. So what we could do is we could just multiply that by 4, right? Because there's 4 atoms of there's 4 atoms of chlorine per molecule. So you could just multiply that by 4, and then you'd get atoms of chlorine. How many atoms of chlorine would be in that many grams or kilograms of CCl4? And so that would essentially leave you with kilograms of CCl4 to atoms of chlorine. And then we could use that conversion factor to our disposal. So let's just go ahead and actually implement this, this plan that we have here. So this is how many kilograms are present. So we know what the question is. We want to go from grams of CCl4 to molecules of CCl4. And we already discussed that the molar mass allows us to do that. So the molar mass of CCl4 is as follows. So there's essentially 12.01 atomic mass units in carbon. But since we're going from molar mass, we want to use grams per mole. And chlorine, or 4 atoms of chlorine, we know that chlorine itself has an atomic mass of 35.45 grams per mole. And then if we multiply that by 4, then we'll get the accurate amount of atoms. So we'll do 12.01 grams per mole plus 35.45 times 4. And then once we do this addition, we would get the total molar mass, which would essentially come about to being 153.81 grams per mole. So, you know, we know that, and of course, this was of CCl4. So we know that 153 grams, or 153.81 or 8 grams equals 1 mole of CCl4. And this mole, in this case, it's talking about 1 mole, not atoms, but molecules, right? Because we're actually talking about a molecule in this case. So really, you could just say that there's, in 153.8 grams of CCl4, there is Avogadro's numbers, 6.02 times 10 to the power 23 molecules of CCl4. That's your sort of your equivalent. And you can see that this matches our plan, right? We wanted to go from grams of CCl4 to molecules of CCl4. But then we said that, okay, we actually want kilograms of CCl4 to molecules of CCl4 to get us one step closer to atoms of CCl4. So, or atoms of chlorine rather. So 153.8, if you convert that into kilograms, you would essentially come about to, let's see here. You get 0.153, so 0.153 kilograms, kilograms of CCl4 equals 6.02 times 10 to the power 23 molecules of CCl4. Because of course, if 153.8 grams of CCl4 has these many molecules, that if you just convert that into kilograms, I mean, it's still the same amount of weight, but it's just expressed as kilograms. So you're not really changing anything. You still have that many molecules in that amount. And then, you know, what we ultimately wanted was we wanted to go from kilograms of CCl4 to atoms of chlorine. And we figured out that, okay, well, there's 4 atoms of chlorine per molecule. So if we just do 4 times how many molecules there are in that weight of chlorine, then we would get kilograms of chlorine equated to atoms of chlorine. So this is not chlorine, this is supposed to be CCl4. So we know now that there's 0.153 kilograms of chlorine or CCl4 equals this amount of chlorine atoms. And this amount of chlorine atoms, if you were to do the math, you would get 2.4 times 10 to the power 24 atoms of chlorine. So ultimately, you know, this is sort of your ultimate conversion factor. That's what we wanted. We wanted kilograms of the compound to atoms of chlorine, and then in order to find out how many kilograms, so now you have this conversion factor, and now that you do have this conversion factor, you can use it in a way that's convenient to get your atoms of chlorine. So it's asking how many atoms, so 7.5 times 10 to the power 25, 7.5 times 10 to the power 25, and that's essentially how many atoms of chlorine are in the compound. And if you multiply that by, you know, one of your conversion factors that will help you cancel out in this case, you have atoms of chlorine here, and then you have your kilograms here. And if you do the math, you'll come about to 4.781 kilograms.